Welcome to the Real Python Podcast. This is episode 135. How do you prepare a dataset for machine learning? Actually, how do you go beyond cleaning the data and move towards measuring how the model performs? This week on the show, Jodie Burchell, developer advocate for data science at JetBrains, returns to talk about strategies for better ML model performance. Jodie starts by defining some terms for the conversation. We talk about targets, features, and supervised learning. Then we discuss 3 common ways data can alter model performance, and which Python tools can help spot and avoid them. Jodie shares personal experiences of working through these pitfalls. We also share a healthy collection of resources to explore and learn more. This episode is brought to you by CData Software, the easiest way to connect Python with data. SQL access to more than 250 cloud applications and data sources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Jodie, welcome back.
Hi, I'm very happy to be back again.
Yeah, you have had a very busy time since we spoke.
Yeah.
You've been doing lots of conferences, been out in the world. I don't know if you want to even give a rundown of some of them, or I would guess some of them have videos posted and we can maybe share a few of them. But yeah, very busy.
Yeah, I've been, I was quite lucky. I got accepted into 4 conferences in a row. So it was exhausting, but it was very convenient. So yeah, I was in Cardiff, then London, then Porto, then Oslo, and just presenting like 4 different talks, total different range of topics. So yeah, it was a lot of fun, but it was good to get home. I could tell you that.
Yeah. You got to meet Gerarna. That was kind of cool. I kept getting notes from both sides there.
Yes, and super funny. So I applied for PyCon US and I asked to be set up with a mentor, and Gian was my mentor. So
that's so funny. Yeah.
Such a small world.
Yeah, totally. Yeah, I think you mentioned that just yesterday to me. I was like, oh, that's hilarious.
Yeah.
And cool. And very, very cool. So
yeah. Well, it was also like a little bit like easier to take feedback from someone when you've met them as well. Not that I have a problem taking feedback, but it always makes it a bit less,
Yeah, there's less yeah, you don't have to like wonder what's behind it. You kind of go, okay, yeah, this person wants what's good for me. So
exactly.
That's cool. Nice. So you're back to talk a little more data science stuff. And this, I thought, is a really kind of cool topic. You want to introduce it?
Yeah. So I want to talk about maybe something that's not discussed, I guess, as a focus of data cleaning, which is how you can actually prepare your data in a way that allows you to understand whether your model is performing as well as you think it is. Like sort of specifically, you train a model and everything looks cool and looks really nice. But when you put it into production, you end up with a nasty surprise where it's really not performing the same well in the production data at all. So just sort of wanted to get into today just a few things to look out for. And of course, because we're on the Real Python podcast, how we can use some tools in Python to quite easily spot those and avoid them.
Yeah, that sounds awesome. I was thinking like kind of a car metaphor. You're kind of like, cleaning the car and getting it all prepped, but you're also kind of giving, once you kind of look at it, an additional sort of tune-up and making sure it's all set. Yeah. That's cool.
Exactly.
So yeah, where do we start this journey?
Yeah, I think maybe let's just start by defining some vocabulary just to make sure everyone's on the same page, and then we can sort of get into talking about the topics themselves.
Okay.
So I think most people who have done any sort of machine learning would know about this, but just in case people are new to it, when you have a data set and you want to use it for modeling, usually you'll need to divide it up into a couple of different sections. So you'll have a variable which is called the target, and this is the thing you're trying to predict.
Yeah.
And then you'll have a bunch of variables called the features. And these are the variables that you'll use for making the predictions. So, I like to always be super concrete with this stuff. Let's say you're trying to predict house prices.
Okay.
The target would be the house prices and the features would be things about the house. So like the condition, the neighborhood, the number of rooms, things like that.
Right.
So we'll be sort of talking about features and targets a bit in this particular podcast. So I just want to make sure, people are not like, what the hell is she talking about?
Yeah, no, that's good. Because features could mean so many different things.
Mm-hmm.
It's very, very specific when we're doing this training and preparing things.
Yeah. And probably the other thing I just want to talk about is what I mean by model performance. So we're specifically going to be talking about a type of machine learning called supervised machine learning. So this is the machine learning most people are familiar with. So things like linear regression models, decision trees, they're all supervised learning. And all it means is you've got basically a ground truth set of labels that you can compare your predictions against. So in the case of house prices, you would have the predictions that your model makes, but you would also have the list of the real house price. And the performance of the model is how close you are in that prediction to the actual, ground truth. So the better the model performance, the closer you are. And that's all we're really talking about here.
Okay. I have a quick question on something, and maybe I'm jumping ahead.
That's fine.
Can you we're going to talk shortly about this concept of overfitting, but can you overfeature? Can you have too many features sometimes? And will that sometimes make things a little too noisy?
That is a great question. We're actually not going to cover it specifically, so it's good that you asked it now. Yeah, this is a phenomenon known as the curse of dimensionality.
Okay.
It's a very dramatic name.
That sounds like a Doctor Who episode or something.
Doesn't it? The curse of the fourth dimension.
Yeah.
But basically what it means is you have so many features that your observations start to be uniquely described by them. So it's easiest to understand, I think, with categorical variables. But let's say, I don't know, you have 3 categorical variables and you have a bunch of really rare groups within those.
Okay.
If you have a combination of, say, the rarest 3 levels or groups within your categorical variable, there might only be 1 or 2 observations that actually meets that. And the more and more features that you add to your model, the more likely it is that you're going to have situations like that. So essentially, what this means is the model can't learn patterns. It just starts memorizing the information that it sees based on 1 or 2 or 3, whatever, observations. Then that's obviously it's going to overfit because it's not learning a pattern, it's just memorizing answers.
Yeah, okay. And I guess that's something you need to do a little bit in advance, or maybe as you're looking at the data initially, you can sort of decide which things hold true signal versus noise or are too static or something like that and only have outliers or something.
Yes, yeah. We will talk a little bit about it. Actually, I tell a lie. We'll talk a little bit about it at the end when we talk about imbalance features. But,
okay.
Basically, this is sort of why feature engineering is such a big deal in machine learning, because you can't just chuck a bunch of unprocessed features generally into a model and expect good performance unless you have exceptionally good data.
Okay.
All right. So shall we jump into the first topic?
Yeah. Let's definitely do it. I think I mentioned it already.
It's okay. So no surprise, the first topic is overfitting. So something I didn't really appreciate when I first started doing modeling is you have a sample, and your sample is a little kind of microcosm of the real world. But your sample will never be completely representative. It'll always have its own little weird quirks and patterns and idiosyncrasies. And when you're training models, the harder you train models to fit your specific training set, the more they're going to learn basically not just the relationship between features and targets, they're also going to learn these weird little patterns that each data set has.
Okay.
And what this means is that when you go and you try and predict on fresh data, your model is not going to perform quite as well because it's just fit way too hard to the training data. So that's what overfitting is.
Yeah, you've kind of looked too closely at it in some ways, I guess.
Yeah, exactly. So I think the way that it was taught to me in a way that I really understood is if you have, I don't know, if you have, say, a scatter plot between two variables.
Yeah.
If you just draw a line through them, that would be like a linear regression model. That's going to give you a pretty good approximation of the relationship between those variables if, the scatter plot is roughly in a straight line.
Yeah, straight line. Yeah, okay.
Yeah. But if you were to draw a line that went through every single point, that's going to describe your data perfectly. But the chances of having those exact same points in a fresh data set is basically zero. So,
right.
Yeah. And when I saw that, I was like,
it's going to be the exact same set.
Exactly. So probabilistically not going to happen. So you can sort of see that the straight line model, even though it doesn't fit the data as well, is actually a better model because it'll predict generally as well on fresh data.
Yeah, give true like direction to things, and as opposed to like trying to be so precise and yeah, it's so weird. Yeah. Okay. I had asked a question in what you had shared with me, some documentation to get us started. And I said, is there a reverse to this? Is there underfitting?
Mm-hmm. And yes, indeed there is. So underfitting is not as big a deal for the sort of stuff we're talking about, but underfitting is basically when you have a model that doesn't learn the relationships between features and targets very well. So you'll generally just have really bad performance like on your training data because, essentially it just hasn't learned enough patterns. So it'll be it'll have quite erroneous predictions. And that's generally, that's what underfitting is.
Okay. It's like almost undertrained.
yeah, exactly. And certain models are more prone to overfitting. Some are more prone to underfitting. So my beloved linear regression is sadly prone to underfitting, whereas things like decision trees are really prone to overfitting.
Oh, yeah. Okay. That makes sense. Cool.
Yeah. If you think about how they work, it makes total sense.
Yeah.
So the way you can avoid this is you basically need to carve off part of your data so that you can have, representation of the real world. This is what's called your test set. So you'll generally set aside like 20, 30% of your data, depending how much data you have. And that'll be the set that you'll use to basically train your model on, the chunk that you've left for training, the 70%, and then assess it on this test set. But there's one further complication. And that's that the test set also has idiosyncrasies. So if you keep training on your training set and then testing on your test set, your model starts to mold itself around the little quirks in both of the data sets.
Oh, yeah.
Yeah. Okay. Yeah. It's always, there's always a trap. So the way to get around this is you basically need to leave your test set so that you only use it once. So you need a second test set that you can use to do this multiple assessment. And then once you come up with a model that you're happy with, use the test set once. And there are a couple of different ways you can do this. The easiest way to do it is basically just create a second test set, and that's called a validation set. And you'll do it the same way. You'll say like 60% for your training, 20% for validation, 20% for your test set. But the problem is that you won't always have enough data. In fact, quite a lot of the time, you won't have enough data in order to create 3 different data sets. And this is where you can use a technique called k-fold cross-validation, which sounds very fancy.
Yeah.
So basically what you do here is you create your train and your test sets. But what you do is you split your train set into k different groups, and they're all equal sized. And what you'll do is you will train on all of your little folds or your little groups within your test group, except for one. And then you'll validate on the last one that you've left held out.
Okay.
And you'll keep going through, and you'll train your model k times, each time leaving a different one of the folds or the groups out as your validation set. And then you simply average the performance of the model across all of those sets. And that basically serves as your validation set without having to explicitly carve out data for that purpose.
Okay. So you're able to rerun and kind of look at what's happening, but is this still the data that is still considered the training data, you're still leaving outside the ones you want to do your predictions on.
Yes, exactly. So you do the K4 cross-validation within the training set.
Okay.
But the general idea is just because you're sort of leaving a small portion of it out each time and then averaging over multiple trainings of the model, you'll get a general sense of how the model would perform on fresh data.
Okay. It's kind of smoothing some of the stuff that in other circumstances with a single look at it could have been overfitted.
Exactly.
Okay.
Yeah. And luckily, so I should say in advance, this episode is going to be a bit of a love letter to Scikit-learn.
That's fine.
It's one of my absolute favorite packages. And for a lot of this data preparation stuff, it has such lovely inbuilt methods.
I could imagine doing that in a very manual sense to be kind of tedious. I mean, obviously you can program it, and what's nice is that they've done all of that and packaged it up and made it pretty straightforward to do, right?
And one of the nice things, we'll talk about it a little bit later, but a lot of the sort of syntax of Scikit-learn is very standardized across a lot of the different methods. So even if you're working with, like, I do a lot of the more kind of basic NLP stuff within Scikit-learn. We talked a lot about that in the last podcast.
Yeah.
But say other types of pre-processing that you would do for data, even if it's not text data, uses kind of the exact same syntax that you would for, say, vectorizing or creating bag of words vectorization for text. So it's pretty cool. And like once you get familiar with it, you're comfortable sort of moving between different methods.
Nice.
So
that's nice that there's like these great like sets of tools that at least you can feel like comfortable that it's following, sets of standards and has methodologies. And it's funny, you shared a whole bunch of links.
Yes.
And we're going to definitely have them all in there. Please check them out. But many of them are diving deep into the documentation and giving you a chance to go in and play with all this stuff yourself. And then we have a couple of real Python things too inside there, which is great.
Yeah. And I think one of the things I really like about the Scikit-learn documentation is, like you said, it has these examples. And I sometimes feel like I barely scratch the surface. Like I start looking for something and I'm like, what is this amazing thing? Like this little tutorial they have. And it's so like interesting. And you go through a tutorial, you learn something completely new when you were just looking for documentation for something else.
That's always great. Yeah. Nice.
Yeah. Bit of a trap though. Rabbit hole.
Yeah, definitely. CData software. Connect, integrate, and automate your data from Python or any other application or tool. At CData, they simplify connectivity between all of the applications and data sources that power business, making it easier to unlock the value of data. Their SQL-based connectors streamline data access, making it easy to access real-time data from on-premise or cloud databases, SaaS, APIs, NoSQL, and big data. Check out cdata.com. That's CDATA.com to learn more.
So going on to the next kind of trap or pitfall.
Yeah.
Let's say we've created our train validation and test sets. Unfortunately, it's not quite as simple as just dividing up your data. There's a few things that can go wrong, and the worst of them is something called data leakage. So
this is something I had not heard of.
My
out of
God.
all the things that we've done, I was like, oh, that's kind of cool. I'm glad to hear this one. So,
man, data leakage, I'll explain what it is, and then I will tell you, it caught me up not even 2 years ago.
Okay.
Like really badly. Like it's a killer. So basically, data leakage is this idea that when you create your train, validation, and test sets, you want them to be completely independent because you don't want your train data to have access to any information from the future, like from the sets that it's trying to predict on.
Right.
And
that makes sense. Yeah. It's very important.
Exactly. Like I think it all makes sense when you think, okay, what you're trying to achieve with these sets is just to create the same conditions that your model will need to deal with in the real world.
Right.
And anything that compromises that is going to affect your predictions. So data leakage is basically where information from the validation and or the test sets manages to make its way into your training data. So in practice, what it means is that your model will have access to information that it's not actually going to have access to in, what am I trying to say? That it won't actually have access to at the time it's making its predictions. So it sort of means that you'll end up with predictions that are much better on your validation and your training set than you would, in reality.
I think I was going to throw one out there. Like, I guess we could use the housing example. This was common in my job in the marketing department that I was working in. There was lots of repetition of data. It just happened. It was a bank. And so somebody could have signed up for a credit card, but they also could be, signed up to having a savings account, having a checking account. They could have all these different types of accounts. And so their data then would get connected to other databases through multiple different kind of queries. And so like that same data could pop in multiple places. And so if we're trying to do predictive stuff, and again, you're looking out in the future and it's like, well, you have the exact same credit card data from, say, like, a really, it's probably not a good term, but like a whale, like a big term, person who's like a big customer for the bank, and they're not only in this test data, but they're also a training data, and then they're in the test data. It would be, I could see that, and that really is what kind of woke me up here. Like, oh yeah,
yeah, yeah, and like I like the example that you brought up with duplicates, because they are honestly one of the easiest ways to understand data leakage. So if you end up with this same person in your training data and also in your validation data and your test data, when the model goes to make a prediction on the fresh data, it's like, oh, wait a minute, I've seen that exact same observation before. So what I'm going to do is just spit out the answer. I know the answer. Like, I don't need to predict. So
ta-da!
It sort of cheats on the test.
Do you mean this person?
Yeah. So the way that we got caught up by data leakage relatively recently was, I was working in my last job. So we were trying to predict people's gender based on their behavior.
Okay.
So what we had was multiple observations for the same person, and we had the target, but the target was always the same gender for a person. So essentially what we did was, we didn't think about this. What we had were very similar observations, because people's behavior is relatively consistent over time, against the exact same label. And we just divided our data up happily across the same data sets. And then we tested out our predictions, and we were getting like 80% accuracy. And we're like, yeah, this is not great, but it's not bad. Like, and we're sort of looking at our features, and we're like, it was things like, I don't know, the amount of time spent at home, the amount of time spent like away on weekends, the amount of time spent on Wi-Fi. And we're like, it's really crazy that we're getting like such good predictions based on these features. And then
they seem kind of
not related.
Yeah, kind of, I don't know, quote unquote weak features.
Exactly. So what we realized is we had a really bad case of data leakage, because essentially it wasn't the exact same observations, but they were so similar with the exact same label. So what we needed to do was obviously aggregate it. And then once we did that aggregation, like our model predicted at like 58% or something. It was so bad. So we were like...
So in that way, like that aggregation, let's say that particular example, how are you aggregating them?
Yes.
And what were the ways of doing that?
What we ended up doing in that case was, we realized the problem was the duplication of the label.
Okay.
So what we ended up doing was, per person, we just had one single observation that was their average, or some, like, depending on the metric, we had different summaries.
Okay. So you were able to narrow it down into a single instance of the individual.
Exactly.
Okay.
And yeah, at that point, all the signal disappeared, but it wasn't real signal. It was data leakage.
Okay.
So yeah.
Is there other ways to notice that? What are ways that someone can try to look for that? I mean, I guess there could be, looking for repeated rows or repeated instances of something.
Mm.
But I'm wondering if there's other methodology.
Yeah, so it can be really tricky to spot. And sometimes, unfortunately, the only time you're going to spot it is when you productionized a model and you realize it's not working.
Okay.
But it can be things like, just check the relationship between your variables and your outcome and, the one-to-one relationships. If you feel like, okay, they're actually really weak relationships, but for some reason my model is performing really well, that should be a massive red flag.
All right. Yeah. Yeah. Like the time spent on Wi-Fi or something like that. Yeah.
Yeah. And it's also like a lot of stuff with machine learning, like it's just common sense. Like it's really not likely that you're going to end up with a super strong predictive signal for gender when basically it's like the amount of time someone spends home on the weekend.
Yeah.
Like it's not a gendered behavior. So
I would think so, but I don't know. That does make sense to me. Like,
it could. Like, I suppose it's sort of like it's a regional thing as well. So like, I don't know, maybe places where there's more traditional gender roles.
Yeah. Okay.
But yeah, like I would say we were just trying to predict for the whole US population. So I don't think that signal really.
Yeah, no, it doesn't seem like a great feature have to do lots of prediction from.
Mm-hmm.
Yeah.
There's one other kind of thing to be careful of, and this is a bit more subtle with data leakage. So basically, there are a lot of transformations that you can apply to text. So again, we talked about those in the last episode when we talked about converting text into vectorized forms. There are certain other transformations. So like one is standardization, which is where you might have a bunch of different variables that are on different scales. So I don't know, you might have the square footage or square meterage of a house, and you might have, let's say, the number of rooms or the age of the house. So obviously they're going to be on quite different scales. And certain models are quite sensitive to that. So you might want to scale them so that they have the same average and spread, like so that, you can compare them.
I could think of an example that having just moved, homes in Hawaii have very, very, very small bedrooms. They're tiny. And that could be an age thing too, like a generational thing, like when was it built compared to, more modern homes. But homes on the mainland of the US, typically the bedrooms are a lot more sizable.
Yes.
Which is interesting. So I could see that kind of that imbalance that could happen. But also I would think of like homes that were built in, say, the 70s or even the 50s or whatever to, the 2000s, I think would be differently shaped in ways of using space.
Mm-hmm, mm-hmm.
Okay.
So this is kind of like a subtlety, but it is something to be aware of. If I were to do that standardization on my variables before I split my data into train, validation, and test, because I used the mean and the standard deviation from the entire population, and it might actually allow my model to have a little bit of a boost up when it comes to trying to make predictions in the validation and the test sets.
It's a bit of, I don't want to use the word sorting, but it's a bit of that in the preparation before splitting things apart.
Mm-hmm, mm-hmm. So this is actually one of the reasons why Scikit-learn has this sort of standardized pipeline. So if you've used Scikit-learn's methods, especially the sort of data transformation methods, what you'll see is that they have this sort of distinction between a fit and a transform function. And they have that with the NLP stuff. They have that with standard scalar, the stuff that you use for standardization. And the reason for that is that you're meant to do your fitting on your training data and then apply that method with the parameters that it's learned from the training data to the validation and the test sets. You should never fit to the whole data and then transform them individually. It needs to sort of learn the parameters only from the training data.
Okay. That makes sense. Yeah.
And then, of course, going away from Scikit-learn for a second, Pandas is obviously indispensable here. So, Pandas has a duplicated method, and, you can also do that aggregation like I talked about using the group by method, do explorations in things like matplotlib or Seaborn just to check the relationships between variables. So all that sort of screening.
And just to clarify on the duplicated method, it's it's basically finding things that it has figured out is duplicated.
Exactly.
And sort of like labeling it for you and highlighting it.
Yeah. So what duplicated does is it will give you an array which will contain like Boolean values for each column. So it'll tell you, there's duplicates in this column and this column and this column. So you can just apply logic to say, okay, give me the columns where there are duplicates, and then obviously work out how to deduplicate them, or whether you can, or, how to go about that cleanup.
Okay, cool. Do you have a set? I know there's lots of people writing scripts or entire programs for cleaning data and prepping it. Is this something that kind of is something that gets prepared after the fact? Or is this still maybe like final steps in that process before you begin to do, testing and training?
Yeah. So this is all definitely pre-training.
Okay.
This is just sort of something that would be worked into your cleaning workflow.
Okay.
And it's just a sort of extra special, very nasty thing to look out for.
Right.
Yeah.
All right. Watch out for these little bits here.
Yeah.
The parts with fangs.
Exactly. And yeah, let's jump into the last trap. This one, I think, is a kind of complicated topic. There's sort of quite a lot of different facets to it. What I kind of want to focus on is we're going to be talking about imbalanced data. And we talked about earlier that we can talk about imbalanced features.
Yeah.
What I want to focus on first is imbalanced targets. And then we can sort of swing around to features if we have enough time.
Okay.
But targets are sort of the worst of them. Like it's I think in many ways more problematic to have an imbalanced target than imbalanced features, but they're both bad. But yeah, let's have a talk about like why it's bad. So if you are trying to predict something that is categorical, so it has groups.
Okay.
It's when basically one or more of the groups is much bigger than the others. So it's like kind of a fancy way of saying it. But let's say, again, I really like to be concrete. Let's say we're talking about house auctions.
Okay.
And let's say we're talking about whether the house sold or not. And let's say, like it's not going to happen in today's market, but let's say that like 90% of the time the house doesn't sell. So that would be an imbalanced target because, one group is 90% and the other group is 10%. So we really kind of have a huge imbalance in the two groups that we're trying to predict.
Okay.
Maybe I should have done it the other way around. The house sells 90% of the time, be a bit more realistic. But basically, the reason that this is problematic is because of the way that machine learning models learn. So what they do is you tell them, okay, here is my metric for measuring performance. And let's say it's accuracy. Accuracy is easy to understand. It's basically the number of times you got the answer right.
Okay.
What you tell the model is to do is please make predictions that maximize my accuracy. So get good performance. And what the model will do is do what it needs to do in order to learn from the features and make those predictions as close to the true answers as possible. But the problem is when you have an imbalanced target, the model can kind of cheat and just guess the majority class. So with the housing auctions model, it could just guess like all of the time that the house didn't sell, and it would still have a 90% accuracy because 90% of the time the house actually didn't sell. So it would be correct. And you can sort of see like, the models can get really lazy and they don't actually learn anything.
So if you're looking for something that is what is the likelihood of this to sell, and you're trying to get a good idea, that's going to be hard to measure when so few things are selling.
Exactly.
Okay, the likelihood of it landing in that is just the current what's happening. And so that's kind of hard to say that this is predictive or not based upon the current circumstance. Okay, and how do you eliminate that?
So there are a few different ways of doing it. So probably like the most kind of, I would say like foolproof way of doing it is to actually balance your data. So you try and do something to your data so that you have roughly, like in the case that we have two outcomes, you have 50% of each of your observations being in, one group or the other. So auction sold, auction didn't sell.
Okay.
So the first way you can do this is what's called undersampling. So basically you take all of those auctions that were not successful, your 90% group, and you basically just randomly choose 10% of them so that you then have a subset which is roughly equal to your smaller group. But you can imagine, again, you need to have a lot of data to do this.
Yeah.
And
to throw away that much.
Exactly. So it's pretty rare that you'd be in a situation where you have the luxury of throwing out like 80% of your data set. Did I do that calculation right?
It's pretty close to it. Yeah.
Yeah, I think so. Yeah. 80% of your data set. So there's kind of an alternative called oversampling. And oversampling is just the opposite. You basically try to get more observations in that 10% group, the smaller group. So like a really dumb way of doing it is, it's not dumb, just a naive way of doing it is you just literally replicate rows. But again, you don't want to do too much of that if your data's super imbalanced, because you're just going to end up with like the majority of the data set is made of duplicates. We've already talked about that.
Yeah. That has its own problems.
It has its own problems.
Yeah.
It also means your model won't learn anything new because you're not introducing any new information, new patterns, like new information for it to make patterns from.
Right. Okay.
So kind of like an alternative that's quite popular is using machine learning in order to do it. So there's like a few different ways of doing this. A really popular one is called SMOTE. So it's basically like a statistical way of generating data based on what you already have. But there's also like in recent times, companies have been coming out with more sort of sophisticated ways of doing this. So I've worked a bit with a guy from a company called Gretel, and they basically specialize in creating synthetic data. And you just use the data you have as a seed, and then it generates more data based on that.
Interesting.
Yeah, so it's pretty cool.
It's grabbing the set of features and sort of creating randomizations in it that kind of work with the rest of the set. Like don't create, does it create its own outliers and other things from the set? Or like, I kind of wonder about like if everything feels like kind of average in that sense or not.
Yeah. So I think depending on the technique used, it'll be more or less sophisticated at doing that. So
okay,
like a really naive way of thinking of doing it is, let's imagine we only have two variables. So we plot everything on a scatter plot, just a two-dimensional scatter plot. And what you would do in order to create new points is you would just start generating points that are close to existing points on that scatter plot. But if you want to do it for 20 features or 20 variables, you would just do that in 20 dimensions.
Okay.
So that would be like a super naive way of doing it.
They would look like little plateaus if it was just the two features.
Yeah, exactly. It wouldn't get too much variance, I think.
Okay.
But, I know at Gretel, they actually do generation of more text data based on GPT-3. Our old friend is back. So
yeah, all right.
Yeah. And with image data, you can actually generate more images by doing things like, flipping around different pixels, by like changing the colors slightly, by adding small distortions in.
Yeah, interesting transformations of things. Okay, yeah.
Mm-hmm. So yeah, it's just a matter of getting creative. And like you can also use a combination of under and oversampling in order to even out your data. So, you're not limited to just one.
What's your experience been using it?
I actually was in a position where I had enough data in this last job where we did have the luxury of chucking out. It was a lot of observations. Like we had very imbalanced data, but we were dealing with something like 170 billion events a day.
Okay, so that's a lot of
data. We were in the position. But I did have another example, and this is actually a good segue about what you can do when you don't have the luxury of balancing your data. So during my postdoc, I was doing some work to try and predict like people's outcomes when they were admitted to hospital with a heart attack. And basically what we were trying to do was like optimize their chances of surviving. So I made this model and I was predicting with like 90% accuracy that people would survive the hospitalization. And I was like, this model is so great. Like, this is good.
Right.
And then I found that it was predicting when people survived. Like, it was really bad at predicting when people actually died. And I was like, God, like, this is a terrible model. So,
is that like the common survivor thing that people present, the airplane, where the airplanes that returned from World War II had survived but had these bullet holes, and people were
survivorship bias.
Yeah, survivorship bias. Is that kind of it, or no?
No. So the data was fine, but my model was not fine.
All right.
And it was because, like, happily, so many people survived the hospitalizations. The rate of death was actually very low. But what that meant was I had to do an adjustment to my model because I wasn't able to balance it in a productive way. It was just too imbalanced. I couldn't drop so much data.
Okay.
So the next way you can do this is by actually telling your model that your data is super imbalanced. And you can do this with both Scikit-learn and Keras models. But basically, you can set a parameter called class weight, and you can say to the model, hey, just be aware, this is not a balanced target. You need to take this into account when you're making the predictions. And it tends to reduce the impact of this sort of imbalance on your models.
Okay, cool.
Yeah. It's really like, again, it's elegant.
Does that move into the hyperparameter kind of realm where you're adjusting these things to kind of tweak the model in some ways, or is it happening before that?
Yeah, it sort of does happen at the model compile or the setting the hyperparameters.
Okay.
Yeah, so it's just sort of passing parameters at the time you train.
Okay, great.
Yeah, and it's like if you Google it, I think I've added some links for it, but it's like super easy to use in both Scikit-learn and Keras because they're both beautiful packages. So.
I'm seeing your fondness for these packages.
Yeah. To be honest, though, like Scikit-learn has always been good since I've been in Python because it's much more mature. But the interface for deep learning has come such a long way since I started in data science. Like, I am actually so grateful for the time that people have put into this because it's now super accessible. So
that's neat. Cool.
Yeah, it's really cool. Like, and again, it's something I think we all love about Python, that it's like such a great democratizer, and you don't need to be like, what's the thing they say about people in Haskell? You need to have a PhD in computer sciences. So that's not us in Python.
Yeah.
Python is for everyone.
This week, I want to shine a spotlight on another Real Python video course. It's about unifying multiple sets of data in pandas. It's titled Combining Data in Pandas with Concat and Merge. This video course is based on an article by previous guest Kyle Stratus, and frequent podcast guest and Real Python author Martin Royce leads you through the lessons, which cover using Concat for combining data frames across rows or columns, building a multi-index data frame, recreating a new index after concatenation, using Merge to combine data on common columns or indices, how to perform inner, outer, left, and right joins, customizing suffixes when doing a cross join, and avoiding common pitfalls when combining data in pandas. Concatenating and joining data in pandas is a frequent task for anyone working with data inside of Python, and I think it's a worthy investment of your time to learn these best practices. Like most of the video courses on Real Python, it's broken into easily consumable sections, and where needed, you get code examples for the techniques shown. All of our courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com.
So the last thing I just wanted to chat about in terms of imbalance targets is model metrics and how we actually measure performance. So we've talked a bit about accuracy, and everyone loves accuracy. It's super easy to understand because, you know, it's literally the percent of predictions that your model got right.
Yeah.
But the thing is, accuracy hides all sorts of sins. And when you have imbalanced targets, it can actually give you a really deceptive idea of how your model's going. Like I was talking about with my survival in hospital model.
Yeah.
My accuracy was great, but the model wasn't good because I actually needed to know equally how many people survived and didn't survive their hospitalization. What you can use is a bunch of other measures that are better at taking into account how well both of your outcomes are predicted.
Oh, okay.
So, yeah. So you can use, there's a bunch that people will have heard of, like precision and recall are probably some of the best known ones. AUC, or area under the curve, is another popular one. Back when I was in epidemiology, we used to use sensitivity and specificity with it, which are the same. It's basically like, well, not quite the same, but the same sort of gist, that it's how many of the positive outcome, the number of people who survived, did the model get right? How many of the number who didn't survive did the model get right? And how good is it at predicting each of those outcomes?
Yeah, I was thinking those terms are real close as far as they're just sort of like, are they on the opposite side of each other? Like you're saying specificity. What was the other one? Sorry.
Sensitivity. Yeah, that's fine.
Okay.
Yeah, so those two are actually like two sides of the same coin.
Okay.
Precision and recall measure slightly different things, but they are complementary measures.
Okay.
And like basically the whole point with these measures is it goes hand in hand with what you actually want your model to do. So do you want your model to be, really sensitive to one outcome or the other outcome? Or do you want it to be really sensitive to both? And that's what you need to think about when you're choosing your metrics and working out, like, even if I've got imbalanced data, even if, my model weights hasn't corrected that well for it, if it really does a good job at predicting the thing that I want, maybe it's an okay model,
Yeah. When were you doing these? Like, how long ago were you? I feel like you've had an interesting career path we've talked about a couple of times, and I'm just thinking of how long ago you were doing some of this stuff that was more in the healthcare kind of space.
Yeah, that was a long time ago. So when did I start my postdoc? I think I started my postdoc in 2012,
Okay.
2013. So yeah, it was a really long time ago now.
So you've seen these tools advance quite a bit, hence some of the affection that you're giving to them now.
Yeah. And it's also, interestingly, like like many data scientists in academia, I started out in R, not in Python. But
yeah.
I don't know if I told you this story. I actually taught myself Python when I was procrastinating one day during my PhD. Like I didn't learn it in one day, but
right.
I decided to pick it up one day.
That's like me on R. Somebody was doing other work in it, and I said, well, I should understand how they're doing it here.
Uh-huh.
Yeah. So it's interesting how you can kind of see the correlations between the two languages. So
yeah, and it's sort of like what I really liked about R, I think, when I was first starting is it was, and it still is, like extremely good for traditional statistics.
Yeah.
Whereas I think Python has caught up on quite a lot of that, but it's really made its mark on machine learning. And it's like the ecosystem is magnificent. It's just
the ecosystem's, I don't think you could compare it. You can try. That was the other thing I was having to be tasked with often was like, all right, we would like this R thing to run in Python, and or we would like this Python thing to run in R. It was like, oh, no. And it was always a little bit of work. It can be done, but it was always hoops and so forth. It would always usually be better if they could stay in their own little ecosystem sometimes.
Exactly. Yeah. And I think this whole debate about like one better than the other is a bit of a misnomer. Like I think they're just better for different things.
Yeah, they were. Yeah. Definitely.
Yeah.
And they might be better for different people too.
I think so as well.
Yeah.
I think so.
Okay.
But yeah, just to sort of round off the discussion about model metrics, as always, there's a whole bunch of inbuilt tools. So one of my favorites is there's a method called classification table in Scikit-learn. So that just basically spits out a whole bunch of different metrics. And if you're trying to predict more than two classes at the same time, it spits it out for each of them. It's like very informative. When you are actually training models in Keras, you can tell Keras which metric you want it to optimize against. So you can actually say, Keras, I actually want you to optimize against the area under the curve, not accuracy. Because,
okay.
So it's super straightforward. The The API is really nice. So
does that let you check your work then to say, oh, I missed for some of these things, or it's either to detect some of these problems that we've just been discussing?
this is more sort of a decision that you would come to. So you'd be like, okay, I've got really imbalanced data,
Right.
and it's important for me to be able to predict both things equally well. What I'm actually going to do is tell the model that it needs to predict, like it needs to optimize not against accuracy, because I know accuracy is not going to help me here.
Okay, because I'm dealing with a lack of
Balanced data.
balance. Okay, yeah.
Yeah. This would be more something you would check again, like as part of that data screening. So like if you're going through with pandas and you run a value count over your target and you realize, oops, like 90% of my observations are in one group.
Right.
Yeah.
Yeah, totally. Okay, nice. You provided a whole bunch of interesting advice here, like different things to look at. And a lot of this is in your article that you wrote on the JetBrains data lore blog. Is that right?
Yeah, exactly. I actually gave a talk about this. That was one of the talks that I gave, the one I gave in Oslo.
Okay.
The recording of that one should be up relatively soon, but
okay, we can always update to include it.
Yeah. And I will actually be giving the same talk on Saturday.
Oh, wow.
I'm heading off to Belgium. I'm going to a conference called Cloud Brew. So yeah, I'll be presenting the same talk that I gave in Oslo there.
Is that, how's that spelled? Is it like the word cloud and then what's the brew? Is this
Cloud,
BRU?
like
or?
brew, like a brewery, because
like a coffee.
The
okay.
whole yeah. Oh, it's actually because the conference is held in a converted brewery. So
oh, okay.
Yeah. It could be an interesting weekend.
Yeah, it's going to be an interesting evening after your talk.
I think so. I am flying the day though, the next day, so I should take it easy.
Be able to make it to your flight.
It's just from Belgium. It's fine.
Yeah. Wow, that sounds like quite the destination place. That sounds fun.
I like Belgium a lot, so yeah, I'm happy to go back.
Cool.
So yeah, I'm super passionate about this topic. Actually, I obviously I'm passionate about NLP as well, but this was more sort of, I guess, where I cut my teeth and really fell in love with like statistics and science in general.
Yeah.
So yeah, like if anyone listening has any questions they want to chat about it, please do reach out to me. I would be very happy to talk to you about it.
What's a good way that people can do that?
So I am on Twitter. We'll post the link to that, I think. I have joined Mastodon, so I've made the leap over.
Which server are you on there?
I'm on Fostodon.
That seems to be the slight consensus in at least my Python group.
Mm-hmm.
I think Brett Cannon was my first leading indicator of there, and then a bunch of other open source people. I was like, oh, okay, we're all kind of moving here, which is good.
I saw the Anthony show was there. And then
him too, yeah.
And then after I moved over, Real Python and the PSF did. And I was like, okay, I chose the right server.
High five.
Yes.
Okay, good. Yeah, we'll include the links for that in case people are not familiar with it. But
awesome.
Yeah, it's been an interesting month as far as how to catch up with people.
Yes. Lots of different ways now.
Yeah, talk about signal versus noise. There's a way more signal there, which I enjoy.
Same. I'm just waiting, I think, for the machine learning community to catch up, because the machine learning community on Twitter is super exciting, slightly overwhelming. It's a bit like a fire hose.
Oh, okay.
But it would be cool to sort of see that same sort of energy over on Mastodon.
Okay. Any other talks coming up? You mentioned the Cloud Brew one, which I think will happen just before this comes out. What anything else planned? Or are you going to be able to take some time for the holidays?
Yeah, thankfully take some time for the holidays. The last conference I have, but I'm obviously not presenting there, is reInvent for AWS.
Okay.
So that'll be end of this month. And then I will be settling in and doing all my Christmas baking and very quiet December planned.
Okay.
Yeah.
Probably heading to, we've been talking about it already, but PyCon in Salt Lake this coming year.
Yes.
And you said you already have the mentor for your talk for that. That's good.
Yeah. I know it's super competitive, so I don't have let's say I'm not optimistic about being accepted, but you got to be in it, so why not?
Yeah, definitely. Any other updates there?
I actually have a couple of cool webinars coming out. Unfortunately, I think one of them is going to be after this, so I won't mention that. But I've got one at the beginning of December where I've got some guys coming on to talk about sustainability research in data science. These guys, I met them at PyCon Portugal.
Oh,
and they're part of a...
Nice.
Yeah. That was such a nice conference. But yeah, they're part of a sustainability research group called Holland. And basically, these guys will take on sort of small contracts and they'll look into how to improve like problems to do with safety and sustainability in cities. So the one that they're going to be talking about on the webinar, which is on December 8th, is about how to increase people's uptake of micromobility. So things like e-scooters, e-bikes, like actually working out whether they're going to make an environmental impact, how that environmental impact can be, most optimized. And yeah, also like some of their other cool stuff was they did this study looking at how they could make dark corridors for bats to fly across Bristol.
Okay.
So that, they didn't make the streets too dark and dangerous for people to walk around, but they also made these corridors so the bat populations could connect together. So yeah, they're doing really cool stuff. So I'm really looking forward to that one.
Yeah, that's fun stuff. So you're sort of hosting that?
Yeah, I'll be hosting them.
Oh, nice.
So I'll send you the link for that one as well. And we can add that to the notes.
Definitely, I'll include it. Well, I want to say thanks again for coming on the show and sharing all this information with me. It's been really fun to talk again. And I hope all your holiday stuff goes great and your upcoming webinar. That sounds fun. And also your visit to Cloud Brew.
It'll be productive, okay? I'm a professional.
Come on, have a couple brews for me.
Yeah, I'll do it. Okay. Awesome. Yeah, it was a pleasure as always. And yeah, thanks again for having me on.
All right, thanks.
Bye.
And don't forget CData Software. Simple cloud data connectivity to SaaS, big data, and NoSQL. From Pandas, SQL Alchemy, Dash, and Pedal. Learn more at cdata.com. I want to thank Jodie Burchell for coming on the show again this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.